Okay, so I'm back again. I realized there was some things that I didn't cover the last time that I talked about Argyll. So today I'm not going to talk about AI like I did in the last video. Today it's just going to be about features and sort of the progress that's being made on Argyll this week because I've actually taken the week off and I spent most of it coding. Let's get into that. I think the first thing I want to show off is just some of the changes that have been made to the UI. Specifically, we'll start with the step editor. It looks mostly the same as last time. You have your attribute editor. This is an input. This is an optional. This is an out attribute. You have the attribute name itself. But one of the things that I've done is I've actually taken the mapping concept from the child step type, and I've just lifted that up and made it a general capability of the server, so it's no longer specific to the child flow. Not yet, yeah. So the way that works is that you could basically just drop this down, and then you have the ability to map the outer attribute name to some inner attribute name, and it's going to be context dependent. Specifically, what I mean by that is for a child flow, it will map to the input attributes of the actual child flow based on the selected goals. For a script, it will actually allow you to just override the names of the parameters that the script will be invoked with. And then for standard synchronous and asynchronous calls, the idea is that it maps to the properties of the JSON that gets posted to those services rather than using the outer names to do it. So you can do some level of mapping. It also has the ability to do basically scripted transformations of the values as well, meaning like you take the outer value and you can either select from it or modify it and map it in certain ways, and then the result is what will get passed to the inner processor, whether it's a service or a script or the child flow itself. So it gives you a little bit more flexibility. That's kind of the idea. So I'm not going to dive deep into that today. One thing you will notice also added recently is JSON path. I call it JPath because I've extended it a little bit. If you're familiar with JSON path, it's a IETF standard for doing JSON selection, somewhat like XPath, but with worse syntax. It's a little bit limited in that any JSON path can only be sort of mounted at the root of the JSON document, and then it's basically a selector, and filters end up being something that you have to explicitly do, even for the root. I've extended the grammar a little bit in a backward compatible way where if you have a filter at the top level, like a top level grammatical production, it will basically treat that filter as if you're filtering from the root, and so the syntax is a little bit cleaner. Like what you see here is that extended syntax, because the way that you would really do this in JSON path is just disgusting. Still bad, but better. And in this case, this is a predicate, and I know I didn't talk about predicates in the last video. I'm going to actually talk about them today because there's something that a lot of questions came up. It's like, well, how do I do conditional logic? And it was always there, but I never touched on it. And this is actually how you do it. I don't want to call it conditional logic. It is conditional, but it's conditional processing. It's not branching. You can simulate a branch by creating like mutual exclusions, but it actually will do parallelization based on the predicate as well, right? It's basically like, hey, I accept this, I'm going to do some work, and it could be that multiple steps accept the same value as well. It doesn't matter, but you can simulate the mutual exclusion if you really want to. But I'll get into that. So let me also show you that I didn't mention this last time either. Steps in Argyll are actually memoizable, and what that means is that by default they're not. So for any set of input attributes, it will always call the backend service or the script or the child flow. It will never skip it, because the assumption is that it's non-deterministic and that if you call it multiple times, it may yield different results, and so you have to accept that. But if you do select memoizable, then what's going to end up happening is the server itself will remember deterministically the inputs and will just automatically provide the outputs to the downstream dependencies without actually executing the work. So it's caching, and it is least recently used. So I can't remember what the limit is, but you can actually change it anyway. But so it'll hold on to those results, much like normal memoization in a functional programming language. That's exactly how it works. But you have to turn it on for it to do it. By default, it will not, and you'll do excess work if you have a very deterministic service or script or something like that. Okay, that said, let me show you another change. The normal UI is this. It's kind of like a normal UI UX with tables and stuff like that. I've also made it so that you can just edit the step description in JSON directly if you really, really want to. The nice thing about this is if you're programming, you could go and make modifications to the table itself and all the fields, and then you can literally get the JSON, and you could use that for like your curl commands or something like that. So it helps with programming to really know what the payload would look like if you wanted to create a step in the server. So there's that if you're really, really interested. So I'm going to cancel out of here. Then I'm going to go into the start flow dialog, and you'll notice that this has also changed. The previous version of it only had the JSON view, meaning that you would have your initial state, which is a JSON document, and it would show you, for example, if you had, well, I'll show you what it used to look like. So here's JSON, right? Required attributes, exactly how it used to look like. If you had a step that had absolutely required inputs, it would tell you, you need to provide values for these three, which is age, credit score, and income. And I'll give you an example. Let's say my credit score is, I don't know, 720, which I guess is reasonable, and my income is 150K, right? So if I were to run that, it ran it, right? So here's your inputs, 53, 720, blah, blah, blah. And here are your outputs. Am I eligible? Yes, I am eligible. All criteria met for the reason, and the risk level is medium, probably due to the salary. I don't know. Anyway, going back, what you'll see now is that there's actually a table-based way to enter this information. And the interesting thing about that is that all of these things are optional, but the good thing about it is now you have a visual indicator that those are actually attributes that you can override in order to influence the processing. What I actually care about is this product info is that actually, and then product name, I don't know, is blah. It doesn't matter, right? And then you close it, and then now you'll see that inventory resolver doesn't need to be called because I'm explicitly providing product info. But you can see it's now a table. You'll also see that there are visual indicators, like this thing will be provided to the server when it gets uploaded. So, there's your JSON, and you can switch back and forth, and everything remains in sync. And so the idea there is that, of course, when you run it, you'll end up with a subset of what would normally be there based on that goal step. Now, in this case, product info, this should fail because it didn't meet the predicate, because I think I used name or something like that. It doesn't matter. Or no, I used product ID, and it's checking on name, and name was not part of the object that was actually passed into the initial state, which you could have done. That said, I want to now move on to predicates because I didn't cover it last time, and I think it needed to be covered. So here's what I'm going to do. This current step has a predicate where it says, I will only work if product info name equals professional laptop. So what I'm going to do is I'm going to go and I'm going to copy this JSON, right? And then I'm going to create a new step. I'm going to call it order creator 2, just to get that out of the way. And I'll switch to the JSON. And the idea there is I'm going to change the predicate. So I'm going to create a mutual exclusion. Now, so if it's product info.name not equal professional laptop, now you have sort of the conditionality, like the branching that you want. But you could do it, the predicate will accept anything. So you could literally have multiple parallel things if the predicates are satisfied. So I'm going to create that. So now I have it. it's going to look like a little bit of a mess because it's weird. So there's order creator, actually, just so you can see it, 2. There's order creator 2, this is order creator 1, right? So this is for professional laptop, this is for anything but. And so what I'm going to do is I'm going to run the flow, and I'm going to provide prod mouse as the product ID, or prod mouse. Wait, what it wants? Yeah, that. So I'm going to process a mouse rather than the professional laptop. And what you're going to see is how the predicate logic actually works. So it's running, 2 things are running in parallel. The downstream, okay, you can already see it. So the original one, because that was not a laptop, it was looking for the laptop itself, is not happy. So this got skipped. And the skip basically is that step skipped because predicate evaluated to false. But this one did not skip because the predicate was satisfied. And so it just ran and it did its thing and it provided downstream to payment processor. And now what you can see is that you have kind of a nice ability to be able to do a lot of different parallel and conditional processing based on these predicates, because they're very cheap. They don't have to call a backend service. They just inspect the data and decide if it's going to be routed forward. And so you can create actually rather complex flows with Argyll. The diagram won't look great, but you have a lot of power in how you actually process things. Yeah, so there you have it. Oh, and by the way, this is a intentional stochastic error. So payment processor itself, the way I implemented it, is it fails like 50% of the time, just so that you can understand how failure actually is handled in the system. And so in this case, it basically just cascades downstream, and then the flow itself can't be processed because the goal step wasn't reached. Another thing, by the way, that I did not cover in the last video, and I will talk about it briefly now, is that I think last time I said goal step, and I kept saying goal step over and over again. But with Argyll, you can have multiple goals. So for example, if I say I want to reach the payment processor and stock reservation, for example, right? Now what's going to end up happening is it's going to show you, actually let me make it a little bit more clear from the diagram point of view. So it's going to be basically payment processor, right? So this is that. It's going to route possibly through these 2 and reach payment processor, and then it stops processing. But then I can also add stock reservation to that. So it'll do both of those. But those are the goals, so it will not follow through to notification sender as well. And so let's run it. You can just see it. Hideous, I know, but this is the execution plan that's running now, and it excludes the downstream step because it wasn't defined as a goal. Anyway, that's running. Another thing, you see the predicates, right? So I gave it the default, which is prod laptop, so it skips order creator 2. There's no reason to run it because it fails the predicate, and here the predicate is satisfied, so it actually passes the value downstream as well. That's it. Those are some of the changes that have happened in the last week, and some of the things that I didn't cover in the last video. So have a good one.